Good day. We presentation our research implementation of STAMM learning technology in the process of calibrating an NTC thermistor and developing an electronic thermometer based of it. The rapid development of information technology, robotics, nanotechnology and biotechnology requires modern education to train highly qualified specialists who can support it, preparing students for producing creative works. Modernization and transformation of the education process is unrealistic without the introduction of innovative technologies. One of the promising areas for improving the education process in STMM technologies short for science, technology and engineers and math. One of the promising areas of STME is STRME, science, technology, robotics, engineers and mathematics, where robotics is a central component among other STMM elements and the engagers in the development and implementation of automatic technical system. The study of the problems of introducing robotics elements into modern education is devoted to the works of many foreign scientists. The analysis of scientific research by leading scientists, the study of their experiments show the need to improve and supplement the development of the methodological system for the implementation of STME education in Ukraine based on the study and implementation of advanced foreign experience and proven practice for the implementation of STAM education. We offer comprehensive laboratory work in physics and methods of teaching physics for calibrating a thermistor. This work can be carried out with students in the physical circle and elective with students of physical and mathematical specification and in the disciplines general physics, method of teacher physics, workshop on school physical experiment and fundamentals of robotics. That theory and practice on this study combined three educational components: physics, mathematics and computer science. The physical component should include knowledge of the foundation of thermodynamics, electric current and the dependencies of the resistance on conductor on temperature and principles of temperature measurements. The mathematical component should include drawing graphs of dependencies between physical quantities and drawn up formulae for the dependence of physical quantities based on the existing graph. The informatics components should include the basics of working with spreadsheets, the drawing to graph and derivation of the formulae for the dependencies of physical quantities according to the existing graph. Research plan consists driving up electronics circuits for calibrating for thermistor, writing a program for calibration a thermistor and programming a microcontroller, gradation of the thermistor using a laboratory thermometer, driving up equation for a dependence of thermistor resistance on temperature, writing a program for temperature measurer and microcontroller programming, decision and creation of an open model of the electrical thermometer, a mercury laboratory thermometer and a thermistor connected to the Arduino microcontroller are installed on the site. In the process of heating occurring water thermometer and in thermodynamics equilibrium with the liquid. Using microcontroller, we read the thermistor reading and enter them to an Excel spreadsheet by readings of a mercury thermometer. Reading date is possible in several ways. One, using the serial port. Two, the displaying information on the screen. To conduct the study, we created a program for calibration the thermistor using the built-in serial port monitor. Based on the data obtained, a table correspondence between the temperature and date obtained by thermistor was compiled. Based on result entered, it is possible to identify the mathematical relationship between the Bausch parameters using the trend line. This will be a formula for calculation the temperature of the thermistor depending on its resistance. By programming the microcontroller, we get an electronic thermometer. To check to the correctness of the calibration, we experiment to compare the temperatures of mercury and an electronic thermometer. As a result of improving the system, we have developed a two-channel electronic thermometer with information output to the digital indicator. This development makes it easily possible to simultaneously measure the temperature at two different points. The development and implementation of Arduino creative projects is possible within the framework such disciplines as computer science, programming, computer science teaching methods, physics teaching methods, general physics, fundamentals of modern electronics, new information technologies and technical learning tools. As examples of Arduino application can be different. The development of the electronic thermometer, a device for measuring air humidity and atmospheric pressure, a device for checking gas low, small home device, and electronic pulse oximeter. So, STM is interesting experiments, scientific experiments, studying the structure of the world and the universe, creating your games, your projects. The opportunity to make inquire discovery, save and make life easy and create something really important for humanity. The use of the Arduino hardware and software complex in education and research activities is a productive tool for the increasing interest in such fields of activity as computer. Thank you.